Hello everyone and welcome to this module on the plumbing trade. In today's video, we will learn to create an internal thread or screw hole on an MS flat or a mild steel flat bar using a tap and also create an outer thread on a pipe using a die set. By the end of this lesson, you will be able to locate holes with a scribing block, drill holes using a pillar or bench drilling machine, determine the tap drill size for internal threading, provide internal threads using hand taps and a tap wrench, cut internal threads using hand taps, select the outer thread providing die set and identify the hand tools, identify the external thread providing pipes and its types, and use the various locking devices. The required tools and material for this are hand tap set 1, pipe vise 1, measuring tape 1, hacksaw frame and blade 1, oil can 1, double-ended spanner 1, ring spanner 1, MS flat as required, oil as required, cotton waste as required, cotter bolts and nuts as required, cotter pins as required, BSP die stock and dies 1, bench vise 1. Let us now learn to cut internal threads using hand taps. Check the material for its size. Apply marking media. Mark the screw hole location on the flat bar as per the drawing dimensions and punch the center of the hole with a center punch. Note that the periphery of the big holes should be punched with a 60-degree prick punch. Fix the job on the machine vise. Also, fix a 4 mm drill in the drill chuck and set the spindle speed for 4 mm drill as it can be used as a pilot for all the holes. Then fix the 8, 10 and 16 mm drill one by one and drill through the holes as per the job drawing. Remember to use a coolant while drilling. Use a drift to remove the taper shank drill from the drilling machine spindle. Adjust the RPM of the spindle to suit the diameter of the drill. Complete the job and deburr all corners. Also, apply a thin coat of oil and preserve it for evaluation. Caution: use the chuck key for tightening the drill in the drill chuck and do not hammer on the drift to remove it out. Next, let us learn to drill holes of different diameters using a drilling machine. Punch the center of the hole to be drilled using a center punch. Set the job in the machine vise securely by using 2 parallel bars to clear the drill. Fix the drill chuck into the spindle of the drilling machine and fix the 4 mm diameter drill in the drill chuck for the pilot hole. Select the spindle speed by shifting the belt in the appropriate cone pulleys. Drill all the holes first using the 4 mm drill. This will serve as a pilot hole for the 8 mm, 10 mm and 16 mm diameter drills. Follow this by drilling the 8 mm and then the 10 mm hole. Once done, remove the drill and the drill chuck. Ensure that the drill does not penetrate into the vise. Then, fix the drill securely into the drill chuck. Since the large diameter drills are thicker, the dead centers of those drills may not sit in the center punch marks. This can result in the shifting of the hole location. Thick dead centers cannot penetrate into the material easily and will impose severe strain on the drill. These problems can be overcome by drilling pilot holes initially. A word of caution: do not remove chips with bare hands. Always use a brush. Do not try to change the belt while the machine is running. While tapping through holes, determine the tap drill size by using the formula or the table and then drill the hole accordingly. Remember that an undersized hole will lead to breakage of the tap. Chamfer the end of the drilled hole for easy alignment and starting off the tap. Hold the work firmly and horizontally in the vise. The top surface of the job should be slightly above the level of the vise jaws. This will help in using a tri-square without any obstruction while aligning the tap. First, fix the first tap or taper tap in the correct size tap wrench. If the wrench is too small, it will need greater force to turn the tap. Large and heavy wrenches will not work to turn the top as it cuts and may lead to breakage of the tap. Position the tap in the chamfered hole vertically by ensuring that a wrench is in a horizontal plane. Exert steady downward pressure and turn the tap wrench slowly in the clockwise direction to start the thread. Hold the tap wrench close to the center. Remove the wrench from the tap when you are sure of starting the thread without disturbing the setting. Make sure that the tap is vertical by using a tri-square which is at 90 degrees to each other. Make corrections if necessary by exerting more pressure on the opposite side of the tap inclination. Check the tap alignment again. This should be corrected within the first few turns. If done afterwards, there is a chance that the tap may break. Turn the wrench lightly by holding at the ends without exerting any downward pressure after the tap is positioned vertically. The wrench pressure exerted by the hands should be well balanced. Any extra pressure on one side can change the tap alignment and cause the tap to break. Continue cutting the thread. Turning backwards after a quarter turn periodically helps to break the chips. Stop turning backwards when you feel any resistance. Cut the thread until the hole is totally threaded. Remember to use a cutting fluid while cutting the thread to minimize friction and heat. Remove the chips from the work and clean the tap with a brush. Once the job is done, clean up using the intermediate and plug tap as it will not cut any thread if the first tap has entered the hole fully. Here are a couple of things to keep in mind during this exercise. Ensure that the diameter of the hole to be tapped matches the size of the tap. Turn backwards to break the chip after every quarter turn. Select a wrench that suits the size of the tap. For the next part, let us focus our efforts on the tapping of cast iron or C.I water lines in domestic water supply. First, turn off the water supply. Mark the position for tapping, which should only be on top of the main. Fix the ratchet brace to the pipe C clamp. Insert the drill as per the marking and drill the hole by rotating the handle and tightening the top screw. Remove the ratchet drill and cut the internal threads with a taper pipe tap. Fit a ferrule to form the necessary connection and then open the valve inside the ferrule and close the cap. Now, let us learn to use the various locking devices. The first part is the lock nut. Fit the locking nut into the bolt and then fit the nut into the bolt. The second part is the castle nut. Fit the nut into the bolt. Then cut a slot in the cylindrical corner on top of the nut and then insert the cotter pin into the slot of the collar. The last part is the slotted nut. Cut a slot in the upper end of the bolt. Then cut a slot in the cylindrical collar on the nut and insert a split pin through the slot of the nut and bolt. Let us first look at using a ratchet type die stock with one handle. Select a set of dies and a ratchet type die stock. Open the adjustment lever. Coincide the 0 setting mark O die stock and then insert the 4 dies according to the number on the dies and die stock respectively. Ensure that the dies sit in the correct position by making sure that the number on the top edge of the die corresponds with the number of the slot into which it has to be placed. Fix the pipe in a pipe vise and tighten to prevent it from rotating. Ensure that the projection of the pipe is within 150 to 250 mm from the vise. Open the self-centering pipe guide and slide the stock over the end of the pipe. Adjust the pipe guide and set it correctly for sliding. Then fit and lock into position. Apply a cutting lubricant to the part which is to be threaded. Always use lubrication oil while threading GI pipes. Apply a little pressure to the stock and keep the handle at right angle to the pipe axis. When the dies cut into the pipe, stop pushing and continue the rotation by moving the handle up and down. Apply the lubricant to the pipe after the first thread has been cut. Keep rotating the handles in the clockwise direction and check the length of the pipe thread. Ensure that the length of the thread is sufficient to fit halfway into the socket or coupling. If the die stock and the die stick, turn the stock anti-clockwise to break the chips. Then reverse the ratchet knob, ease the handle and turn the stock anti-clockwise till the stock and dies come out of the pipe. Clean the thread with a wire brush. Form a thread until the pipe extends about 1 or 2 threads beyond the end of the stalk. Remove the stalk and dies by operating the quick release lever and clean off the thread with a wire brush. Check the formation of the thread with a standard fitting. Repeat the operation if the thread is too tight by adjusting the ties. Now, let us look at using a 2-handle stalk and dies ratchet type. Open the vise and insert the pipe into the pipe vise. Then, close and tighten the pipe vise. Open the self-centering pipe guide and slide the stalk over the end of the pipe. Adjust the pipe guide for correct sliding, then fill and lock in position. Apply a cutting lubricant to the part to be threaded, then apply heavy pressure to the stalk and keep the 2 handles at right angles to the pipe axis. Rotate the handle clockwise with heavy pressure towards the pipe in a plane right angle to the pipe axis. Apply a lubricant to the pipe and keep rotating the handle clockwise. Check the length of the pipe thread and the thread with a socket. Remove the stalk and die and clean off the thread with a wire brush and cloth. In this lesson, we have discussed how to locate holes with a scribing block, drill holes using a pillar or bench drilling machine, determine the tap drill size for internal threading, provide internal threads using hand taps and a tap wrench. Cut internal threads using hand taps. Select the outer thread providing die set and identify the hand tools. Identify the external thread providing pipes and its types and use the various locking devices. Hope you have a clear understanding of this session. Thank you all and see you in the next video.